Okay, so I'm really sorry, there was a network issue. Suddenly it got disconnected. Okay, so shall we start? We'll wait for another 1 minute. Okay. So what I was telling here was, when I'm talking about carboxylic acid, although if it is not getting dissociated, but still there is a presence of lone pairs of electrons. There is a presence of lone pair of electrons. So due to that, that lone pair will be exchanged with carbon. So that's where we have the OH. That's where we have the OH. This can be the situation with respect to the carboxylic acid, because there is a presence of lone pairs of electron with oxygen. Now based on this, can you tell me what is that difference or condition with respect to carbonyl carbon? If you compare aldehydes ketones and if you compare those things with the carboxylic acid, what will be the feature of or condition of carbonyl carbon? Anyone? What will be the condition of carbonyl carbon? Everything I have shown it there. Partial positive, okay, partial positive, or I can tell that if you observe here carefully, this carbon will not be electrophilic as that of the carbonyl carbon in aldehydes and ketones. It will be less electrophilic. It will be less electrophilic, because if it is feeling electrophilic character, there is an oxygen which will be investing the electron. It will be investing the electron. So therefore, this carbon will feel less electrophilic character. But if I take aldehydes as an example, if you observe here, if that is the case, that means this carbon will be straight away will feel positive character. Straight away it will feel the positive character. That's what. As Sanjana, she has written partial positive charge. Same logic is applicable here. I am telling in a different way. I am talking in terms of electrophilic character. So what I mean to tell here is, compared to aldehydes and ketones, carbonyl carbon of carboxylic acid will be less electrophilic in nature. They will be less electrophilic in nature because of this particular nature, or because of OH group which is attached to this carbon, because of the OH group which is attached to this particular carbon. Whether I am clear? So therefore, carbonyl carbon of carboxylic acid will be less electrophilic in nature. That is one thing. And second thing is, carboxylic acid is an acid because even at acidic pH it can donate the H plus, because whatever product will be formed, that is carboxylate, it can be stabilized by the resonance. It can be stabilized by the resonance. So these are the reasons why carboxylic acids are having acidic character. One thing. And why carbonyl carbon of carboxylic acid are less electrophilic in nature. So these are the two important points where they differ from aldehydes and ketones. Although all of them they are having carbonyl group, but still carboxylic acid they differ from aldehydes and ketones. because of these two major points. Okay? Fine. So now we will move to the nomenclature. Now we will move to the nomenclature. When I am talking about the naming of the carboxylic acid group containing molecule, all of us we know that name should be ended up with oic acid. Name of the molecule should be ended up with oic acid. Say for example, I have CH3COOH. How many carbons are there? 2 carbons. So 1 and 2. Same as that of the aldehydes. Same as that of the ketones. Here also functional group carbon will be considered under the main chain carbon itself. So that's where we have the 2 carbon. That means it's the ethane derivative. So we will call it as ethanoic acid. So that's where oic acid. When it comes to aldehyde, it used to be Al. When it comes to the ketone, it used to be O, O-N-E, O. Here it will be oic acid. Okay? Now, if it is in dissociated form, then name of the molecule should be ended up with O8. Name of the molecule should be ended up with O8. That means ethanoate. Ethanoate. That's where O8. So dissociated form, non-dissociated form. So carboxylic acid, carboxylate. So that's where ethanoic acid, ethanoate. So that's where we have the 2 different forms of the molecule where based on their functional group, whether it is dissociated or whether it is non-dissociated. Okay? Now, when it comes to priority wise, functional group priority is there, right? Which people have studied in your first PU, basic concepts of organic chemistry. So carboxylic acid will be having highest priority. Next comes the sulfonic acid. Okay, priority wise, carboxylic acid will be at the top. Wherever in any organic compound, if carboxylic acid is there, the name of the molecule should end up with oic acid, no doubt. Okay, so that's where we have the functional group carboxylic acid. When I am talking about same molecule which I had written, normally it will be called as acetic acid. That is because this molecule is majorly component of the vinegar. It is the major component of the vinegar which we'll be using in cooking and all, right? So therefore, it is based on that they have given the name as acetic acid. Because in Greek, if I am right, in Greek, acetum, Greek or Latin, that's why, acetum means vinegar. Acetum. Oh, they are there only. Yes, Meghana. Yeah, it was buffering. Now, okay. So it's clear, sir. Okay, done. Okay. So all of you are here, right? Okay, less students only, but still fine. So that's where we have the acetic acid. This is a common name which is derived from the acetum. That means vinegar. Same way we have HCOOH, which is actually a methanoic acid, But commonly it is called as formic acid. That is because formica means and. So that is because Formica means ant, because this molecule formic acid is majorly found in the ants. Okay, so that's where we have the yes formic acid, that is because of the formica ant. Same way, if I take CH3, CH2, CH2, COOH. So this is called as butyric acid. This is called as butyric acid. That is once again because of the butter. Butyric acid is because of the butter. Butter will be having odd smell, right? Especially if you store the butter for a long time, then it will give the odd smell. So that is because of one of the reason is butyric acid. So that's where butyric acid, it is from the butter. So what I mean to tell you is we have most of the name of this acid. The common name is because of their source. From their source, they have kept the name of these molecules. Okay? Now, when I am talking about these molecules, all of you can see their name is ending up with oic acid, no doubt. Their name will be ending up with oic acid. When I am talking about IUPAC name, not with the common name. Okay, acid will be the common this one, but when it comes to IUPAC name, either it will be oic acid or ic acid. Anything is fine, oic acid or ic acid. So that's where we can observe. Name will be ending up with oic acid or ic acid. That's where we have the name of the molecules. Okay, so butyric acid can be written as butanoic acid. Propionic acid can be written as propionic acid. So that's where oic acid I was telling. Fine. Now at the same time, we have some of the molecules which will be having more than one carboxyl group. We have some of the molecules which will be having more than one carboxyl group. That's where this molecule, if people have studied in titration, this molecule if people have studied even in salt estimation also. So this is nothing but oxalic acid. Oxalic acid. So it is a common name. It is called as oxalic acid. It's a common name because it was majorly found in the flowers of oxalis family. It is majorly found in the flowers of oxalis family. Yes, Archit, that's why it is called as oxalic acid, common name. But what can be the IUPAC name? Oxalic acid is not the IUPAC name, and it is one of the important component of kidney stone where calcium oxalate will be there. So most of the kidney stones is due to the coordination complex of oxalate and calcium. So that's where calcium oxalate is the important component. So dicarboxylic acid, only that much? Dicarboxylic acid, only that much? What about backbone? 2 carbons are there, right? What about backbone? Ethane dioic acid. Ethane 1,2-dioic acid. Okay. Archit, naming, numbering may not be required here. You can simply write it as ethane dioic acid. No doubt. Ethane dioic acid. Okay, that can be the IUPAC name. So numbering is not required, I told, because it's understood that these 2 carbon, whatever this 2 carbon is there in ethane, both of them they are in the carboxyl form. So therefore ethane dioic acid. What my point? So that's why we have the oxalic acid IUPAC name. Same way we have another dioic acid which differs from the oxalic acid by having one methylene group. by having one methylene group. Okay. Now this molecule is commonly called as malonic acid. This molecule is called as commonly as malonic acid because once again in Greek or Latin, I think in Greek, malon means apple. Malon means apple. They first found it is in the apple, that's why they kept the name it as melonic acid. They kept the name it as melonic acid. So what can be the IUPAC name for melonic acid? What can be the IUPAC name for melonic acid? Anyone? What can be the IUPAC name for melonic acid? Okay, propane dioic acid. Very good. So propane dioic acid. Propane dioic acid. Very good. So that's where we have the IUPAC name for the butyric acid, melonic acid. Okay. So next one. COOH, CH2, CH2, COOH. So this molecule is nothing but succinic acid. I think this molecule, biology students, you people have studied in citric acid cycle. This molecule you people have studied in citric acid cycle. Yes, Archit. It is succinic acid. Okay. So what is the difference between malonic acid and succinic acid? One extra methylene group. That means in malonic acid, 3 carbon structure. In succinic acid, it is 4 carbon structure. Can you tell me what will be the IUPAC name? IUPAC name for succinic acid? Butane dioic acid. Yes, it will be butane dioic acid. Now I will increase the number of carbon. COH, CH2, 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 COH. Even this molecule, related to this molecule, you people have studied in citric acid cycle. Once again, biology students, even people have studied this one in the citric acid cycle. Archit, ethane 1, 2. Okay, done. Then you can tell, yes, you can tell that ethane 1, 2 dicarboxylic acid. Yes, you can mention that one. But normally it is called as butane dioic acid, or we can call it as ethane 1, 2 dicarboxylic acid. Acceptable. Done. Okay. So butane dioic acid or ethane 1, 2 dicarboxylic acid. Okay. So glutaric acid. Yes. That is succinic acid because it is found in amber. Succinum means amber. Okay. So same way here we have the glutaric acid. Common name. Glutaric acid. What can be the IUPAC name? What can be the IUPAC name? What can be the IUPAC name? Pentane dioic acid. Yes, no doubt. Pentane dioic acid. Okay, which will be the proper IUPAC name. Or we can even call it as Archit has told here, we can call it as propane propane 1,3 dicarboxylic acid. Or propane 1,3 dioic acid. Fine, that is also fine. So dicarboxylic acid. But actually this is called as pentane dioic acid. So pentane dioic acid. Fine. So that's where we have the another molecule, that is glutaric acid. We have the molecule glutaric acid. Then we have 6 carbon. We have the 6 carbon CH2, 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 COOH, which is called as adipic acid. Which is called as adipic acid. Now when I am talking about adipic acid, adipose tissue, we will call it as adipose tissue. In biology, students will be knowing. What are adipose tissues? These are the tissues which can have the capacity to store the fats. Right? So same way when I am talking about adipic acid, it is majorly found in animal fat. Adipose means animal fat. So based on that, they have kept the common name as adipic acid. Yes, Sanjana, fast storage tissue. So based on that, they have kept the name it as adipic acid. Okay. Now, what will be the IUPAC name? As we know, it's a 6 carbon containing molecule, hexane dioic acid. Hexane dioic acid. Or we can call it as 1, 2, 3, 4 butane 1,4 dicarboxylic acid. No problem. Butane 1,4 dicarboxylic acid. Okay, so that's where we have the name of the molecule. That's where we have the name of the molecule, IUPAC name. Fine. So pimelic acid and heptane dioic acid. Okay, so that is not there in your this one. Otherwise, the list will go on. Okay, we will stop here because when it comes to IUPAC name, whatever normal they will ask, whatever related to your textbook. Pimelic acid and all, it's not there. But when I am talking about these things, normally they have not asked. I think once they might have asked with related to melonic acid or adipic acid, something. So therefore I was discussing about this one. Fine. Otherwise list will go on. It will never end. Okay. So that's where we have the molecule of another one. Yes. Another one, because these things you people have studied in another topic also. So this is nothing but phthalic acid. Common name will be phthalic acid. Common name will be phthalic acid. Now what will be the IUPAC name? What will be the IUPAC name? Phthalic acid is the common name. You people have studied this one in reactions earlier. So what is phthalic acid IUPAC name? Benzene 1,2-dicarboxylic acid. Okay, benzene, no doubt, benzene 1,2-dicarboxylic acid. Or some people even they can call it as benzene 1,2-dioic acid. No problem. Benzene 1,2-dioic acid. No problem. But this will be more appropriate. Benzene 1,2-dicarboxylic acid. Fine. So that's where we have the IUPAC name for phthalic acid. So you can Try to learn related to succinic acid, adipic acid, phthalic acid and all. Okay. Now we will go to in-text question 12.6. In-text question 12.6. They have given the molecule structure. You have to tell the IUPAC name. Okay. So what will be this molecule? This is related to in-text question. What will be this molecule? Anyone? What will be the IUPAC name for this molecule? As it is in your textbook, I have written 2-phenyl propanoic acid. Okay. So really it is 2-phenyl. Archit, in a hurry you might have written. Yes, it will be 3-phenyl propanoic acid. 1, 2, 3. So therefore, 3-phenyl propanoic acid. pH means phenyl. Okay. So 3-phenyl propanoic acid. So next one they have given as CH3 twice, then C, CH, COOH. Yeah, CH, COOH. What will be the IUPAC name? This is done. 3-phenyl propanoic acid. Three-methyl but-2-enoic acid. Okay. All of you will agree with that? That is absolutely correct, because I can write this molecule as CH double bond, CH double bond C, and that's where one methyl group is there and another methyl group is there. So it is a butane derivative. So 1, 2, 3, 4. So I can write it as 3-methyl but-2-enoic acid. But-2-enoic acid. Absolutely correct. So 3-methyl but-2-enoic acid. Okay, that's where we have the IUPAC name of the molecule. 2-isopropyl. 1 minute. 2-isopropyl ethanoic acid. Okay. So yes, we can call it as, it should be isobutyl, not isopropyl. It can be isobutyl. Okay? Because 1, 2, 3, okay, this is isopentyl actually. If you take it backbone, why you are taken ethanoic acid as the backbone? No, Archit. Ethanoic acid cannot be acting as a backbone here, because we have a linear chain of 4 carbon and there is a branch. It can be isopentyl. It cannot be ethanoic acid as a backbone, we cannot consider. Okay? So therefore, it can be either isopentyl derivative. If you talk about pentane as a this one, then isopentyl. But isopropyl ethan, okay, no, backbone cannot be ethanoic acid. Okay? Got my point, Archit? Okay, no, that's fine. You have tried, I appreciate, but that's fine. No problem. Okay? So next one. CH3 COOH. Okay. So what will be the name? Hmm? What will be the IUPAC name? Two methyl cyclopentanoic acid. 2-methyl cyclopentanoic acid. Okay. I was actually expecting that one, but more appropriate can be 2-methyl cyclo. So 2-methyl cyclo pentane carboxylic acid. Carboxylic acid. 2-methyl cyclo 1, 2, 3, 4, 5. Okay. Cyclopentane carboxylic acid. Why I have written? Yeah, some people have written, I think, carboxylic acid. That is because if I tell pentanoic acid, sometimes it will lead to like this carbon is part of the 5 carbon molecule. But that is not the case. This carboxyl group is outside. So this will be more appropriate if I mention it as carboxylic acid. If you remember, benzene carbaldehyde we used to call, right? So benzaldehyde, or to be more appropriate, benzene carbaldehyde. Archit, yes. Pentanoic acid, fine. Cyclopentanoic acid, it's understood that carboxyl group should be outside because within the cyclopentane ring carboxyl group cannot be there. That's fine. That's correct only. But it will be more appropriate. That's all I mean to tell. Okay? So it can be 2-methyl cyclopentanoic acid. It's understood that carboxyl group is outside the ring. But it will be more appropriate. Just like benzaldehyde, it's correct only. But we used to call it as benzene carbaldehyde to be more appropriate. Okay? Fine? Okay. So that's why we have this molecule. And I think the last one is easy. And the last one. COOH, NO2, NO2, NO2. Okay. What will be the name? Anyone? Okay, I think network is slow. Okay. At once it came. 2, 4, 6 trinitro benzenoic acid. 2, 4, 6 trinitro benzoic acid. So 2, 4, 6 trinitro benzene carboxylic acid. So okay, priority I will give it to Sanjana. Last girl is Sanjana. Yeah, she has written. So 2, 4, 6 trinitro benzene carboxylic acid. We can call it as benzoic acid, no doubt. But as I told, it will be more appropriate, carboxylic acid. Or if you write 2, 4, 6 trinitrobenzoic acid, you are going to get the marks, no doubt. They are not going to deduct the marks, but it will be more appropriate. Okay? Now I will write, I think you people have studied this one earlier. What is this? Just tell me the IUPAC name first. Oh, it's not related to your in-text question, just I remembered. What will be the IUPAC name? Archit is telling catechol. Okay, Archit. If it is catechol, okay, you deleted. Since carboxyl group is there, it cannot be OL. 2-hydroxybenzene carboxylic acid. Very good. So this is nothing but 2-hydroxybenzene carboxylic acid. Only this much you people are remembering. This is one of the important molecule people have studied. 2-hydroxybenzene carboxylic acid, known with one common name. You people are studied as important reactions. It is salicylic acid. It is nothing but salicylic acid. Coal-base reaction. Not only that, we have the derivative of salicylic acid, that is aspirin. That is aspirin, acetyl salicylate or salicylic acid. So that's where we have the aspirin, right? So that's where salicylic acid. Okay. So anyway, I will stop here. Okay, Archit has written. Even Brinda. Okay, very good. So that's where we have the salicylic acid. The IUPAC name of salicylic acid will be 2-hydroxybenzene carboxylic acid or 2-hydroxybenzoic acid. Anything is fine. Okay. So 2-hydroxybenzene carboxylic acid or 2-hydroxybenzoic acid. Anything is fine. Okay. So shall I stop here? Any doubts? Another, I think, maximum 2 class. This topic will be done. And I think it will be offline class. Okay. Thank you. Thank you very much. Take care. Okay, na? Bye.